November 2016, paper 6, variant 2. The question is about the separation of mixture. The diagram shows 4 sets of apparatus that can be used to separate the mixture. Complete the boxes. Okay, this is the condenser. Of course, you can say Liebig condenser, but it's not needed. You can only say condenser. And this is the tripod. Okay, the table shows 4 different mixtures, and he needs you to say which set of apparatus could be used to obtain the substance listed. So the first mixture is petroleum and water, 2 liquids. Of course, they will be separated because they're immiscible liquids. They will be separated by the separating funnel. Sodium chloride dissolved in water, and he wants sodium chloride crystals. It will be separated by crystallization, C. Sodium chloride, and he wants the water. Sodium chloride dissolved in water, and he wants the water. We will use simple distillation, which is D. Insoluble silver chloride and water, and he wants the silver chloride, which is the insoluble solid. We will use filtration, which is A. Put a ring around the separation method that should be used to separate a mixture of colored dyes. Colored dyes are to be separated by chromatography because they have different solubilities. Okay. Second question, take care from the second question, is investigating the rate of reaction between dilute hydrochloric acid and excess magnesium. Since he said that magnesium was excess, this means that the hydrochloric acid was the limiting reagent. The reaction finishes not when everything finishes, only when the acid finishes. Okay, and this is not a burette. Take care from the labeling. This is not a burette, should be graduated. This is not a burette, this is called a tap funnel. Okay, this is called a tap funnel. Okay, he said what he did, 30 centimeter cube of the acid were added to a magnesium ribbon, and then he measured the volume of the gas collected by a measuring cylinder. Take care, whenever you're measuring a gas underwater, there is a risk that some of the gas may dissolve in the water. There is a risk. Most gases are soluble in water, and even if a gas is not very soluble, some of it may dissolve. Every gases are soluble to different extents, okay? If some of the gas dissolved in the water, the reading here will not be accurate. The measurement of the gas will not be accurate, okay? So he asked you to take the readings. These are the readings. Take care of the measuring cylinder is inverted, so you should invert your paper in the exam and read the readings from here, from the top to the bottom. Okay, sorry, from the bottom to the top. 44, 57, 62, 78, 85, 88, 89, 90, and 90. Then he asked you to draw a graph. The graph is the one in blue, as best as I could. It's the one in blue. There is an anomalous result that we don't pass through. This one, you even don't pass even if he didn't ask about it. You don't pass by a point that disturbs the shape of the curve, okay? Which result is anomalous? You can say the result at 60 seconds. The result at 60 seconds, or you can say the third result. Suggest a possible reason for this anomalous result. Why is this result anomalous? He misread the measuring cylinder, error in reading the measuring cylinder, or he read too early. He took the reading too early because it seems in volume collected at this timing should have been higher. So he might have read the volume too early, okay? Just think of a simple error that he might have done during the experiment. Use your graph to deduce the total volume of gas that you would have expected to collect instead of this anomalous volume. In other words, he's saying what was the supposed volume at this timing. You will draw the 2 perpendicular lines that show how you've got your answer, okay? And you will draw the line till you hit the curve and read the y-axis. It will be 68. Any answer from 68 to 70 is acceptable. Okay. Next question. He wants you to explain why the total volume of the gas collected does not increase after 160. Okay. Whenever the volume of a gas or anything like this happens, the rate becomes 0. You know that the reaction has finished, but you always lose 1 mark in this question because you don't say which reactant is used up. You must go back here and realize that the hydrochloric acid is the limiting reagent, and you must say the reaction has finished because all the acid, which is the limiting reagent, was used up. Okay, question E. The average rate could be calculating using this formula. Then he wants you to calculate the volume of the gas collected between 20 and 40 seconds. The best thing is to do is to get them from the graph, okay? So 57 minus 44. 57 minus 44 is 13. Then he says that you can calculate the rate, by this formula. So you got the volume of the gas, 13, over the time interval from 20 to 40, which is 20 seconds. It will be 0.65, and you always forget the unit. Centimeter cubed per second. 0.65 centimeter cubed per second. You can get it from the graph, centimeter cubed per second. Okay, the unit of the rate is always something measured over time. F, sketch on the grid the graph you would expect if the experiment was repeated at 30. It was done previously on 20. Of course, a faster rate means we go away from the time, okay? Steeper curve, and it finishes at the same level because he didn't change the concentration of the limiting reagent. When you don't touch the limiting reagent, the graph always levels off at the same point. Okay, so 1 mark because it's steeper, 1 mark because it levels off at the same point. G, suggest why the reading on the measuring cylinder was 30 centimeter after the acid has been added and before the timer has been started. This is not an easy question. He says at the beginning, before we start anything, there were 30 centimeter cube of gas collected. What happened? Okay, the reason for that is that some air was displaced when the acid was added. Yani, he opened, okay, in order to add when you added the acid, some air, hydrogen was produced, but it pushed some air in this delivery tube, okay, and the air displaced the water. Then the hydrogen came and started filling the measuring cylinder. Some air was pushed from the conical flask and it displaced the water in the measuring cylinder. That's why the reading was 30 before we start anything. This is the volume of the air that displaced the acid. Some air was displaced when the acid was added. Okay, suggest and explain one improvement to this experiment. You could measure the volume of the gas using a burette or a gas syringe. I prefer, of course, a gas syringe instead of the measuring cylinder because it's more accurate. Yani, he could have measured the volume, okay, by connecting this delivery tube. This delivery tube could have been connected to a gas syringe instead of this measuring cylinder, or at least he could have used a pipette or a burette here instead of the measuring cylinder because it's more accurate. The other option that you could have said, when you want to improve the experiment, you could say repeat the experiment and take average results. Okay, take care. He always asks to improve the procedure, or to improve the apparatus. When he says improve the procedure, you can always say repeat and take average. You can always say it when he says improve the procedure, okay? When he says improve the apparatus, you must say something like this. You must talk about the apparatus he used. When he says how to check the reliability of the results, this is something third. When he says how to check the reliability of the results, you repeat, but you don't take average. You repeat and compare the results, okay? يبقى repeat and compare when he says reliability, repeat and take average when he says improve the procedure, and then you find something wrong in the apparatus and you improve it if he says improve the apparatus. If he left it open, just an improvement, you could say either an apparatus related improvement or repeat and take average. Cations and anions, 2 solutions S and T were analyzed. S was HCl, and he doesn't say anything about T. Okay, HCl, and he's saying what's the pH? Anything from 1 to 3. Please don't choose 0, as it's very hard to have an acid with pH 0. Just choose a reasonable number from 1 to 3. Test 2, copper oxide was added to the second portion of the solution, and the mixture was heated. Okay, now take care. Copper oxide is added to HCl. Copper oxide is a solid that will react with HCl. Whenever you put a solid that reacts in a solution, okay, or in an acid, you must say that the solid dissolves or disappears. And this is a very famous mark you lose, okay? You don't say that the solid disappears, you just search for, search for the gas, okay? Here, solid dissolves or disappears. This is the first thing. Copper oxide plus HCl will give me copper chloride. Copper chloride is green in color, okay? Copper chloride solution is green in color, green solution formed, or you can say blue solution formed. Yani, he accepts blue, but the more accurate answer is green. Test 3, he added to the acid sodium carbonate, okay? And he is asking for the observations, and he told you that the gas was tested. So you must say that the solid dissolves, This you forget also, the solid dissolves, and then you can say bubbles of a colorless gas which turn lime water milky. Lime water for 1 mark, milky for 1 mark, and the solid dissolves for 1 mark. Test number 4, dilute nitric acid and silver nitrate were added. Silver nitrate is the test for halides. Okay, we have hydrochloric acid, so the halide is chloride, white PPT is the answer. Now here he's testing for T. Okay, T, he divided it into 3 equal portions. The solution is yellow. Think على طول transition metal is present since it's a colored solution. Then he added drops of sodium hydroxide, red brown PPT, insoluble in excess, which is indicative of iron 3. And then here he added sodium hydroxide and aluminium foil. Aluminium foil is the very special test for nitrate. If it's positive, it produces ammonia, which is a pungent gas and alkaline. So we have iron 3 nitrate. If you didn't say iron 3, if you didn't say the 3, you lose a mark. Final experiment is electroplating. This is electroplating experiment. It's very important to know. He wants you to electroplate a metal ring with a copper rod. And he said, include, you must include the label diagram in your answer. This is the diagram, okay? Take care about a mark if you said that you clean the metal ring with sandpaper. This is important, okay? To clean the metal ring with a sandpaper before you start to remove any impurities and to allow easy, smooth electroplating. Then he gave you copper sulfate crystals and water. You need to say that you will dissolve the crystals in the water, or at least write on the graph that this is copper, on the diagram that this is copper sulfate solution. Set up a circuit. You take the mark from the graph if you just drew the circuit correctly. The anode is the copper rod. The cathode is the metal ring. Rotate the metal ring, okay? This is a very smart mark. Rotate the metal ring continuously in order to make it electroplated from all directions, and then remove the ring and wash it and dry it. You can take any 6 marks from these 7 points. Okay, there are only 2 points you cannot get from the diagram. Cleaning the metal ring with sandpaper and rotating the metal ring. It's not that obvious on the diagram. You can show them easily, but you can take